Hello everybody, I wish you're doing well. Welcome to my channel. Today we will do a new tutorial about a workpiece called chainsaw. Simple. mm, Chainsaw is here. We'll open it. So business as usual, we will work on this workpiece. We will start by creating block, calculate this block. We'll put it on global transform coordinate system and we will accept. Then we'll start by creating an end mill. So it is our tool. We'll see an end mill of 20 millimeters, for example. Or we can delete this uh, holder by clicking here, and we will search for one if we have here in the tool database, but we don't have a tool holder in the database, so we will create it with 30, 20 here. An overhang of 18. Then we will create another. This is another holder with a length of 26, for example. We will close it. Then we will create our toolpath of model area clearance. Then we will choose the offset all. That's good for us. Choose a step over of 6. We can change it a spiral one, and we can add a step cutting and normal finishing. We don't need it. Remove segment smaller than threshold. We don't need it. We can let all this as it is. We can just change some leads and links. Then so for lean, we prefer to put a ramp because it will help us to machine to do our leads directly without breaking the tool. So we can put it on circular arcs, for example, if the distance is less than 10. We calculate the toolpath. Here what we have. So we will have rest material here. We can also create stock model to put all our toolpath to see what will happen directly. Here what we can add, we can for example add automatic collision checking for checking the collision and to have this in blue to confirm everything. some region machine as expected. Yes, it's not a problem. We'll do another. We will do another machining next time. So let's simulate it. So this is it. Then we will create another tool to enter here and do all this material also here and here. So let us calculate also our stock model. So here what we will have after the first toolpath. Here is what we will have. So to do this, we will create a smaller toolpath. We can, for example, as a trick, we can go directly here and directly duplicate our toolpath. We will have it here and directly put it into maybe 10. I can't change this, but the first one. So now we can change first one. Where is it? Just see here. But we have the second that is put in the toolpath. So the first didn't change, so we will create a model rest clearance area, a model rest area clearance. So with using the first tool, so it is like this. It's not very logic, but we can change settings, change the shank with clicking on it and put in the lower diameter. And then, for example, we can also put the upper diameter, but this doesn't really matter. So we will directly calculate. According to reference, we will do the toolpath. You can choose the first toolpath. We will see the tool chosen. We will use the same parameters, maybe less here and less here to have a better model rest area clearance. We'll hide the stock model. We'll see what we will have. We'll have this, but what I want is that the tool goes into here. So let's just erase this with clicking in delete and create directly a model area clearance. So I will calculate. So let's just see and measure length, 20 22 millimeters. Maybe we'll create a ball-nosed uh, tool will be there. Then we'll create a layer holder of 20 in the upper diameter. Then we'll open this and see what will happen with this new tool. So with a ball nose tool, it goes everywhere. So let's just erase the first toolpath. So it is in stock model, so we have to remove it first and then remove this, so we can simulate this to see what will happen. So now I am showing you how to use PowerMill, but because every time you will have to verify your toolpaths, you will verify if your tool is good and if it can go into uh, the into uh, the stock model and the rest material that you want to do. So every time you have to try multiple tools to see if you can go with it. I will put more speed. Oh, it finished. So here we can go step by step uh, with when we use simulation step by step, we'll go into every point. And the red points are points of in general G0 or G1, and the blue points are points of G2 or G3. It is a rotation with I and G coordinate. So you can just hide it. So with this we can do now our model rest clearance. We'll choose this one. Why do we have these problems? Because we have put the same step over. Let us just put a smaller step over. We'll just stop it here because I will put also a smaller thickness, 0.5. It will take some time to calculate it. I think with using the stock model, it will take will take fewer time because it is more it is easier to calculate with it. So here is the toolpath. You can simulate it. The hydro speed. This is the toolpath. So now we will put it in the put the two new toolpaths, select them and put them directly in stock model and calculate. We will hide the toolpaths. Here what we will have. So now what I will do is to do a finishing toolpath to be sure that we will have the area that we want. So I will use this one, optimized constant Z finishing with spiral and with smoothing. Here we have automatic verification. We can also put some 5-axis machining. I don't know if it will do it, but we will use this algorithm. Put it in one here also, and as 0 thickness, then we will calculate. We can also optimize this toolpath by just selecting this as a limit here to just work on this or with this to optimize this toolpath. But we can do this in another video. You can just ask me in the comments about what you want. So here is it. Uh, Here it is. So we will calculate the stock model and we will see what we will have. We can put also a toolpath into shaded. So here what we will have in the end. So we can also from this create the NC program. So we'll just option file. We will choose Fennec post processor. We forgot also to create a work plane. We can create a work plane to create our NC program. So to return in it, just we can go into settings. Use this for tool numbering. We will put it into automatic. I don't know what is this bug with PowerMill. We cannot have access to the to click here. So what I do, so we will continue through choosing the parameters of the NC program, but to select this, we can't go into apply, accept, and close. I don't know if it is a bug or, but what I do is I go here and edit settings. We can just work with this smaller edit selected NC program box, apply and accept. So we can write it here. Let's see, current oil due to the following no toolpath. We also forgot as the last time to put toolpaths, so we can just put them here. We repeated number 2, then number 1, and then number 3. Oh, we will write. So it is post-processed, and we will open an external program. Open it. So here is the G code if you want to put it directly in the machine, but it is better to develop your post-processor than post-process your program, then create it. So thank you for watching this video. I hope you have enjoyed it, and thank you for watching.